Hello everyone, I am Dr. Tanmoy Biswas. I welcome you all in my channel TanmoyChem. Today's topic of discussion is on MCQ and the question is in front of you. What is the major product of this reaction? I request everyone please pause the video, try by yourself, and whatever answer you get please write in the comment box along with few words as explanation. I believe we have tried, so let's start. Now question, major product of this reaction. So this is actually benzene and this is bromide, aliphatic bromide, AlBr3 catalyst. What is the product? And from all four options, I guess you understand it is a kind of aromatic electrophilic substitution. AlBr3 act as Lewis acid catalyst. So this is now question, what will be the product? So let's learn the mechanism. Now first is actually electrophile generation, because the reaction I am talking, it is aromatic electrophilic substitution. Now if you look at AlBr3, it is actually a covalent molecule. Yes student, only AlF3 is ionic, AlCl3, Br3, I3 all are covalent molecule. Now from here you can understand this is a 2 electron, this bond is 2 electron, this bond is 2 electron. So how many electrons are there around this central atom aluminium? 6 electrons. So you can say it is sextet or incomplete octet. Means its octet is not fill up. Nearly 2 electrons still needed for this octet fill up. So that's why it acts as a Lewis acid. Now fine, Lewis acid is this one. Which one acts as Lewis base? Actually this bromine. Why? Because this bromine has 3 lone pairs. So one of them could be donated to this central atom aluminium. Fine. So in this way it will form a acid base adapt. So this is bromide. Now bromide gives electron to this AlBr3. So AlBr3 will have a formal negative charge and bromine will have a formal positive charge because it has donated electron density to this aluminium. Consequently, bromine will have a deficiency of electron which is designated or indicated by this positive charge. So this is the thing. Now still this molecule is fine. Now positive charge on halogen is not stable. So what it will result? It will result breakage of this bond. So this bond will be taken. So what will be produced after this? So here you can understand it will result a carbocation. More specifically, if I say it is actually a primary carbocation. Now we know that primary carbocation has relatively lesser stability, and if it is possible, such carbocation can rearrange to more stable carbocations. Now here two pathways possible for such kind of rearrangement. So one, these hydride could be migrated from this carbon to this carbon. I repeat, hydride migration means you may consider this hydrogen is migrating with its bond pair, I mean 2 electron. So this side is CH3, no problem. This side is positive charge. This is option number A. And option number B will be the migration of alkyl group. Means these alkyl group will migrate. So what it will result? Student, in this situation, I suggest everyone to draw this way. Keep every bond as it is and just change this bond which is broken and produce. So now positive charge is here. This thing I can write little better way, this 5-member ring with this. Now we will see, sir, it is a very easy thing. Why you want to make it unnecessary complicated? Yes, I agree, unnecessary complication. But if you have a big molecule, that time this strategy helps a lot. Means many time I observe when some big molecule, some rearrangement reactions are given, then student get confused. They end up in mistake, ring number change, carbon number different. So in this way you can avoid those mistakes. So this is the electrophile. Now why not this one? Here it is tertiary and here it is secondary. So why not? So here if you look at carbocation, remember carbocation center is actually sp2 hybridized. So you may consider that there is a p orbital vacant. Now sp2 hybridized. So logically this angle must be 120 degree in case of sp2 hybridized or closer to 120 degree. But if you look at this angle, it is 90 degree. If you look at these angle, you will say, sir, it is nearly 107 degree, agree, but that is far more closer to 120 degree compared to 90 degree. So you can say this carbocation is associated with ring strain or angle strain, means less stable. compared to this one. So that's why this secondary carbocation will be produced as the intermediate, and it will act as electrophile, and it will participate in the next step of reaction, that is aromatic electrophilic substitution. I guess this is very easier to you. So this will attack here. Now obviously from the beginning there was a hydrogen in both cases. Now since this attack took place, consequently this benzene will lose its aromaticity. So this is hydrogen, and here the 5-member ring, and everything as it is. This is hydrogen, there is positive charge, because see, it's a positive charge. This benzene is a neutral molecule, so neutral molecule plus positive charge means positive charge. Since benzene gave its electron density to this carbocation, so benzene will have a positive charge. Now previously look at this benzene, it is aromatic, resonance stabilized, but in this case aromaticity is gone. Now some of you can say, sir, aromaticity is gone but still resonance exists in this way. So this double bond will come here and we can draw this canonical form. There is a 5-member ring and positive charge goes this. By the way, further, sorry, double bond is not this, this is not, it will be attached here, this carbon. Okay, there should be hydrogen. Now so you can say, sir, this structure possibly, yes, another canonical form also possible, but I'm not going that much. But one message I want to give, that whatever you are saying, okay, because of resonance this positive charge is stabilized, I agree. To some extent this positive charge is stabilized, but remember this molecule is not that much stabilized like the parent benzene, because it is aromatic, means very stable. Now remember, when molecule loses its very high stability because of some reason, it tries to gain back that stability. Now in this case, how it can gain back its stability? By releasing this proton. So this proton goes and this 2 electron comes here. What it result? It result in this benzene derivative, again obviously attached with this 5-member ring. Now clearly you can understand this proton is substituted by this 5-member ring. So that's why you can say it's an aromatic electrophilic substitution, because this molecule is actually our electrophile. So this is the overall discussion. Here AlBl3 act as a catalyst, and through rearrangement, or more specifically if I say, it's called as Wagner-Merwin rearrangement, where primary carbocation is rearranged to secondary carbocation. And why not tertiary? I've explained. So that secondary carbocation further react as electrophile and resulted in this aromatic electrophilic substitution. So what is Wagner-Merwin rearrangement? So it is actually a class of, this is a rearrangement which happens on carbocation. In this case 1-2 rearrangement reaction takes place, in which could be hydrogen, alkyl group or aryl group migrate from one carbon atom to the neighboring carbon atom. So you can see here this positive charge actually come from here to here. So hydrogen one time migrated, another time this alkyl group migrated. So that we want to say, and this is facile and it can take place even at low temperature also, and it follows the order, that is carbocation stability order, means tertiary carbocation is more than secondary carbocation, more stable than primary, and methyl cation. Very often students do mistake, they remember this tertiary then greater than secondary than primary, but they forget methyl. Student, remember this part. Methyl cation is actually different compared to primary carbocation. As for example, you can say ethyl cation. Now, so this is the overall discussion of what is the major product of this reaction. Here option B is the right answer. Now if this question appear in your exam, how can you come to the right answer in less time? First look at what kind of reaction is taking place. In presence of AlBr3 there will be a cation production. Is this cation stable? Is Wagner-Merwin rearrangement possible? Yes. So these will not be the major product. This is a process of elimination, very helpful in solving MCQs. Now which one will migrate? So if hydrogen migrate, as I told, the produced carbocation has some ring strand, so this option gone. So now carbon CC bond moves, so okay, looks like this option. Now what about the option C? Now here for option C we need a dication preparation, but under this reaction condition dication preparation not possible. Second thing, student, always be careful about carbon count. Here it is a C4 plus 1, so it is actually a C5 group. So if aromatic electrophilic substitution takes place, the 5 carbon will be attached to benzene. Look at here, not 1, 2, 3, 4. So understand, you may be confused that sir, this option looks little difficult. Actually it is not, it is a vague option. Based on common sense you can eliminate this. So actually you should eliminate this option first because carbon number doesn't match. So in this way you can solve, but one thing I believe, this much amount of logic is difficult to call out in the exam hall. So that's why much reading as well as much practice needed. And as always I say, write everything on a pen and paper, then you can remember better. So this is the overall discussion. Thanks for watching, and if you really enjoy the content of my channel and if you really consider my contents unworthy, then please help this channel. And if you have any doubt about the logo of my channel, please read this part. So see you in my next video. Bye bye.